Okay, so this is a video to help you guys with part 3 of the project. So really it's part 3B. In part 3A, what you should be doing is you should, first of all, it doesn't say it, but put some mass in the box. If you don't put any mass in your icebreakers box, it's just going to flip over. And so all you do is you pick a stretch and you're going to stretch it that certain amount and you're going to launch it until you get your launching technique down and it stops at approximately the same location. And so what I've got here is I've got some information. So here, this first line, that stuff, the mu, the K, the mass of the box, and the added mass, that stuff you know going into actually stretching and launching and testing your box, okay? So mass of the box you can do by just weighing it at my digital scale. Adding a mass, you pick an added mass. I would pick something between 50 and 100 grams. That usually works the best. So then down here, you guys chose, we're just saying, theoretically, you chose to stretch it 0.35 meters, which is 35 centimeters, right? And then you launched it. I would say we're going to be looking to launch like at least 10 times until we consistently get it to land about the same spot. So in this theoretical situation, it was landing 5.7 meters. It was stopping 5.7 meters from where you launch it. So what we're going to do is we're going to do part 3B. So it's going to you're going to figure out what's the efficiency of this launch. Okay, so let me get rid of this. So we're going to start with our good friend E1 plus W equals E2. And when it starts, we've got EPE. So EPE1, we know we've been talking about work of friction. And then E2 is where it stops, and that means there's zero energy. So what you're going to find here is when we calculate EPE, so EPE1 is 1/2 kx squared, which is half of, what did we got? Our K is 20, and our X is 0.35. Oh, I'm running out of room. We're going to square that. Okay, when you go through that, we get 1.225 joules. Okay, so EPE1 is 1.225 joules. So I'm going to write that up here. Oops. I don't really know how to write now. All right, we're not going to write that. I'll write it here. So I'm going to keep track of that because I'm going to get rid of this other stuff. So I have more room for W friction. Okay, so we're expecting that W friction should also be 1.225 joules, but just negative. And what we're going to see is that it's not actually. So let me get rid of this. Okay, now we're going to calculate W friction. So W friction is the force of friction times the displacement. Force of friction is mu times normal force. Okay, and then we're also going to multiply that by displacement. So force of friction was mu normal force. Okay, normal force is going to be this equal and opposite to force of gravity. So we're going to get that that should be mu. Normal force will be mg and then times d. Okay, all right. So I'm going to run out of room again, but that's okay. Actually, I can probably just scroll up. So we've got 0.3. Yep, I'm going to scroll up. Okay, so we've got 0.3. The mass, let's go back up. So for mass, we have a mass of the box is 14. The added mass is 50. These are both grams. So we know the total mass is 64 grams. But we're going to convert that to kilograms. So 64 grams, we take the decimal and we move it 1, 2, 3 to the left. So we get 0.064 kilograms. So 0.064. That's our mass. Our G is 10. And our displacement, I think I said 5.7. Okay. All right. Okay. I'm going to put a negative sign in front of this because we know the work of friction is always negative. So when we multiply those together, we get a negative 1.0944 joules. Okay. Now when you look back at what we said up here, EPE is 1.225 and work of friction is negative 1.0944. So when you add those together, you won't get 0. So from here, EPE1 plus W friction should equal 0, but it doesn't. So that means there's some extra energy that went somewhere else. We don't know where it went because definitely we had 0 energy at the end. But work of friction, so basically the WF, we assumed that total work was just work of friction. Obviously, there's something else taking energy away. We don't know what that is. We don't know how to account for that, or calculate that. So what we're going to do is account for that in efficiency. So let's see. I'm going to get rid of this stuff. And I'm going to write down that my WF is negative 1.0944 joules. All right. So efficiency is how much energy we have left, or how much energy we can account for of the original energy. So basically, and we can get it from E times EPE, or E1, plus work equals 0. Okay, so the little e times E1 plus work equals 0. So we're just going to plug some numbers in. We're going to solve for E. So the little e times the 1.225, okay, plus the work, so that's a negative 1.0944, is equal to 0. Okay, so when we solve that, we're going to just add we're going to do a plus 1.0944 to both sides. You got it. So we'll get E times 1.225 is equal to, those cancel out, 1.0944. Okay, so to finish this up, all we have to do is divide both sides by 1.225. And what we get is that E equals 0.893 ... You guys just need to round to the nearest percent, so that would be, we move the decimal over 2, so we get 89.3%, which gives me 89%. And that would be your efficiency.